As per usual, we'll be focusing on work in the industry on MaterialX and related technologies like USD, MDL, and OSL. And we're going to leave it to the teams that are working with the technologies to talk about their latest work. And then we'll have a Q&A session afterwards where people can ask questions, and either of us or the presenters today. Let's see, let me get the overview. So this is an overview of the presentations we'll have today. This is a pretty amazing lineup. I'm really excited about it. We'll be starting off with the introduction of a brand new surface shading model called OpenPBR, which is a collaborative project of Adobe and Autodesk over a good period of time. And that'll be presented today by Guido Quaroni, Adrien, Herubel, and other representatives of the Adobe and Autodesk teams that worked on this very impressive project. That'll be followed by updates on technology for material and USD integration, Hydra as well. And that'll be presented by Lucknavalai from Pixar USD, one of the leads of the MaterialX USD integration. That'll be followed by a presentation on LookDevX in Maya, a long-awaited project that we're really excited to see finally come to fruition. That'll be presented by Nikola Milosevic at Autodesk. After that, we'll have a project that you may not be aware of. It's the Strolla MaterialX editor. This is a project of IKEA and will be presented by Magnus Pettersson. This is one that we're also really excited about, and we're happy to have a chance to make this more known to the community so that people can essentially understand what things are possible today. That'll be followed by a presentation on MaterialX and MDL, some technology updates from Rohmer at NVIDIA, and then a presentation on RenderMan and MaterialX from Manca at Pixar RenderMan. And then finally, following up on an FMX 2023 presentation, we'll have the Quilts graph editor presented by Manuel, Köster, and Richard Frangenberg, respectively, from Remedy Entertainment and Prism Pipeline. Really excited about all of these. And I will hand it over to Guido, who will start the very first talk today.
Thank you, Jonathan. Hi, everyone. So today we want to talk a little bit about OpenPBR, and you may wonder, what yet another material model. So this is just to give you a little bit of an intro here. About a few months ago, this is a discussion obviously that a lot of us has been having over the years, like how do we help artists to really be able to move across application. And material is, and this is obviously the big effort with MaterialX, to try to improve interoperability. And Adobe produces a bunch of applications, and so either between our own application, this is a key aspect, but even more, we realize also that users use all of them, not just the one from a given vendor. And it always seems to be, I think that we're kind of getting a hold of the geometry side, but on the look side, and definitely, again, a lot of effort there. We are still receiving a major complaint there. And so the Adobe had his own material model was introduced about 2 years ago. And we had other big material models out there like, Autodesk Standard Surface. And so we thought about it, is there a way to actually to simplify, innovate, and, and always think about the artist versus saying, well, I got this new cool feature, so I'm just we're going to do our own thing and prove that we're better than everybody else. And in a way, we thought, okay, let's have a conversation, and that's how we wanted to connect we connected with Autodesk, and they were more than eager because they were thinking along the same lines about, can we actually look at those two material models and see if we can come back with something, taking the best from both of them, and obviously we'll transition to this new one and make it open and be part of MaterialX. We really believe in MaterialX. Both companies are investing actively into this space. And ultimately, so we don't create a new governance model. We don't have people to join other things. We're just going to say we're going to be part of it as a sub-project. And that's what we did for the last few months. And I'll obviously want to give it to the rest of the team to talk about it. They did a great job to really synthesize the two systems together. Try to, again, not to be too picky about names and parameter range and everything, and really look at the fundamentals and come up with something that we hope will be interesting to a bunch of other people out there. And obviously, again, keep it in the spirit of being open. So that's pretty much it. I don't know if you want to roll with a little video, and then there's going to be more Peter and others talk about more of the technical stuff. Yeah, so this is a work in progress. We want to be make sure, and so then we again being definitely for on the be thinking about really the artist, and again MaterialX, what I just said. Right now we did a bunch of try to come up with something that works and renders. We're still really work in progress, and there's still differences. Some of that may be data transfer, some of it may be some nuances, also because it depends also on the how you lit the scene. But this is an example of a scene in Maya and a scene in one of our tools using Arnold and the Adobe proprietary path tracer. And again, they're not pixel to pixel perfect, but we really want to put forward that you can make judgment calls. The idea will be that you'll be able to make really, really even definitive judgment calls by looking at images produced by different systems, so you don't feel completely out of the way when you switch to between application using this model. Okay, then I think somebody's.
Thank you, Guido.
Yeah, go ahead. Sorry.
All right. So practically, OpenPBR surface is a physically based surface model that is based on Autodesk surface and Adobe standard material. This means that it's designed as a Nuber surface, and it aims to be capable of accurately modeling the vast majority of materials used in production. It is not a reinvention of the wheel. It is an evolution of two production-proven models with a clear continuity, as shown by how close the layering diagrams are in all three models. The parameters are designed to be intuitive and to ensure that the users work within the bounds of what is physically plausible as much as possible, though because it is meant for production with the ability to tweak reality in well-defined ways and achieve exactly the look they want. And users of both models or any PBR model will find the familiar metal, glossy diffuse, specular, translucent, sheen or fuzz, SSS components that they already know how to use well. All right, next slide, please. So our goal is to create a surface shading model that is able to faithfully represent a wide variety of real-world materials. And real-world materials such as finished wood, cloth, skin, they all comprise in semi-transparent layers of matter that is stacked on top of each other. And we follow that by defining the model and describing the physical structure as unambiguously as possible, rather than by specifying a particular form or implementation. And this is done by specifying two basic operations, like layering and mixing, and to provide a language for building a model of a material consisting of vertically layered slabs of material with structure that is varying horizontally over the surface, especially varying BSDFs. And this formalism is general enough to describe arbitrarily complex materials. So the specification is written for implementers, and the specification is written so that people can implement it in their renderer faithfully. And we are ourselves working on implementations of OpenPBR in Autodesk and Adobe software. And that's based on specification, but also on a MaterialX specification and implementation, which should be able to be consumed as is in renderers supporting MaterialX. And for more details on what we changed in both our models, I want to give the floor to Peter.
Thank you. All right. So for OpenPBR, we tried to take the best of both worlds from Autodesk Standard Surface and Adobe Standard Material. And we'd like to quickly share a few examples. First, inspired by Standard Surface, OpenPBR has a dedicated subsurface lobe in addition to the interior volume. And we've also improved the parameterization to be even more perceptual and art directable. On the right, you can see a few renders of a shadow edge on a material with subsurface scattering. The scatter radius now controls the average distance that light travels along the surface after multiple scattering. So the overall subsurface effect looks similar regardless of the color. The rightmost material has forward scattering. We have formulated anisotropy in such a way that it does not affect the overall color or scale of the subsurface effect, while still giving you the edge softening and directional effects that you would expect. Another example is metal reflectivity. OpenPBR inherits the F82 tint reflectivity model from the Adobe standard material. This model takes two parameters, a base color and an edge tint with a default value of 1. This lets you accurately reproduce the dip in the reflectivity of real metals near grazing angles, while also being highly art directable. The render on the left shows a variety of real metals using base and edge colors derived from the measured spectral data and the full Fresnel equations. The images on the right show a few examples of this model applied to a metal sphere in a white furnace. Intuitive results are produced for any combination of base and edge colors. Finally, there are some aspects of OpenPBR that are different from both the Adobe and Autodesk models. For example, we've moved the sheen or fuzz layer on top of the coat layer. This reordering increases the number of use cases for fuzz. For example, in addition to being useful for fabric, fuzz can now be used to model a layer of dust on top of car paint or any other material. And now over to Fred to wrap things up.
Thanks, Peter. So right from the start, the collaboration between Autodesk and Adobe has been done with great spirit. And we quickly felt that we were going to be able to converge to a common model. So I'd like to thank both teams for making it happen and striking the right balance between expressivity, physical correctness, and ease of use. OpenPBR not only eases the exchange of assets between software vendors and between studios, it also presents our common users a familiar set of parameters and concepts in the multiple applications they use in production. We're thankful to Jonathan Stone and the MaterialX project to host the project under the ASWF governance model. This clearly states OpenPBR as an open standard. We also want to thank the people from Blender, Side Effects, Sony, NVIDIA, Epic, and others who gave us early feedback on OpenPBR. And as a testimony, I'd like you to look at this render from Chris Rydalch from Side Effects. No, sorry, previous slide. That was done with the OpenPBR MaterialX definition in Karma. So OpenPBR surface is a first step. We plan to start working on other production material models such as hair or volume next, and we need your help. Next slide, please. So those are the main contributors of OpenPBR. OpenPBR, I'd like to conclude by saying that OpenPBR is not just a spec. We're committed to shipping it in our products. So come and see us at the Autodesk booth on Wednesday and Thursday at 11 a.m. So some of those contributors will be there to discuss anything about OpenPBR. It's going to be very free form, very informal. So yeah, come and meet us and let's discuss further. Thank you.
Should unmute myself. Sorry, so talking about MaterialX and the improvements that have happened over the past year or so. The first most notable change that happened is that MaterialX is now enabled by default. So anyone who goes to the GitHub repo to get USD will get all of the MaterialX support as well. We also now support up to MaterialX version 1.38.7, and the big headliner item there is that metal shader gen was added. So now you can use a USD file with a MaterialX material and render it on any device that uses metal now. And if you actually look closely at these two images, they were both rendered in just that way. Some other improvements that happened this past year are adding some more flexibility with how you can define your materials themselves. So MaterialX is extremely flexible, and some of those changes, like I said, have been to allow for more of that flexibility to be used inside of a USD context. And so what I mean by that is that you previously had to be a little bit careful as to how you could define your nodes and node graphs and how you could implement those, but now there's a lot more flexibility there, as well as what you can name your material itself. There's also a lot wider support for custom nodes. Again, this was previously pretty limited, but now you can have locally defined custom nodes. So you can define your custom node in the same MaterialX file that you use it. You can also put it in a separate file and use an include or use an environment variable. There's a lot more flexibility with what you can put inside your custom node now as well. You can use textures and texture coordinates where you couldn't do that before. We also had a lot of good pull requests, one of which was from Autodesk, which added a bunch of properties that are now parsed into the SDR node. And that SDR node is basically how we're getting that MaterialX information into Hydra. And so with all of these additions, now DCCs can make use of all this information without having to reparse any MaterialX definitions. Another bit of work done this past year was to align the math used in the native USD and MaterialX implementations of Preview Surface with the goal to use MaterialX's node graph as the mathematical definition of the USD spec'd out Preview Surface material. And if we look at the image here, we see that the native USD implementation of Preview Surface is on the top and the MaterialX implementation is on the bottom. They're not quite perfect yet, but they're getting a lot better, and we hope to get them even closer in the future. We have tests that are directly comparing these two implementations, as well as a bunch of other imaging tests that are testing the various aspects that we support within the MaterialX integration, and they are now all on the GitHub repo. So hopefully with these accessible to everyone, we can now have a lot more collaboration and improvements to this integration moving forward. When the initial MaterialX support was added, Storm actually didn't support that many different light types. That, of course, is not the case anymore. And this has now been extended to all of your MaterialX materials. We also have the start of initial material caching. Right now, this does only work for simple materials. And what I mean by that is they are ones that only consist of a USD preview surface or standard surface or whatever type of material node. They do not have any other nodes or node graphs that are feeding into that node for like the diffuse color or roughness or something like that. And what's cool about the image we're seeing here is that these are 6 simple standard surface materials. So they're all being rendered with just the one shader. And again, this is just the initial caching. We hope to extend this in the future to accommodate more complicated materials. Oops. Some PRMan specific improvements include that we have added support for displacement, which we can see with this very cool test image here. This was done by Adrien on the PRMan team. She also added a couple smaller fixes for some texture coordinate name mismatches that was happening, as well as some normal mapping fixes. Again, these are specific to PRMan, and there are still more issues that we'd love to be addressed in the future, some of which include some normal mapping issues that we're aware of in Storm, as well as color space handling, which I'll personally be working on in the near future, and with the goal of that being added to the 23.11 release. Yeah. So that's it for me. If you're curious about any other updates or improvements to USD and Hydra, make sure to come to the USD Hydra BOF at SIGGRAPH, literally a week from today, from 2 to 4. Yeah, that's it. So I'll hand it off to Nikola, Autodesk.
Thank you, Karen. That was awesome. Let me check to where I am. Okay, cool. Hey everyone. So anyway, my name is Nikola Milosevic. I'm a PM for lighting and rendering in Hydra for Maya and 3ds Max. Today we're going to go over the LookDevX project status, and additionally I will share some of the other Autodesk team's work and their contribution to open source projects. Before we go there, before we make our hands dirty, I need to show you our safe harbor statement, which basically tells you that statements I'm about to disclose or are forward-looking statements, and they're not promise or guarantee of future availability in our products. Okay, that's out. So anyway, we had released LookDevX in Maya 2024. For those ones who didn't have a chance to see it, LookDevX is agnostic material authoring tool, which is currently resolving natively USD material story. It's engineered to be used like in a different DCC, and it's actually fully Arnold supported. Something we promised a long time ago, we are currently actually implementing MaterialX as a second native material authoring option. Regarding what we delivered in the 2024 release, there's a numerous features. I'm not going to go over that. You can skim it through it, but however, right now I'm going to go and show you some in-progress work that we are more than happy to share with you and with the larger audience who's going to watch that after. So one more time, this is in progress. So the first thing is that color management is absolutely fully supported right now, obviously using the OCIO. Relative texture paths are supported. That's quite impressive and work done by our team. Obviously, input color space rules is run by the Maya color management system. You can select multiple materials and graph it out one or more in your LookDevX. Regarding material assignments, they're all direct material assignments so far. You can do it through Outliner, or you can do it through the viewport, and we are actually supporting multiple scopes and multiple stages. You can assign it actually through the material through the LookDevX 2. Copy paste, it's very much like done, and it's actually going to be used a lot. So you can do it between the stages if you want. Backdrop is fully supported, as you can see it in the screen. Solo workflow for the LookDev is going to be like quite awesome, and it's working obviously in viewport and the Arnold render. Geo subset workflow or perfect shading for some of the people is fully working, and there's a run tree between Maya and USD is working fine. Okay, Bifrost USD. So Bifrost USD is our answer for a pipeline-friendly late material assignment and procedural material assignment. We are developing simple process where geometry variants and the geometry representations or purposes can be assembled easily with numerous material variants and looks. So the whole process is aimed to be pipeline and user-friendly, where you can assemble products from multiple departments with just a few clicks. So I don't know if you noticed, but it's like we only have these 3 type nodes here that can actually assemble multiple geometry and material variations. So Autodesk graphics platform team actually delivered 5 patterns to actually contribute 5 patterns to the standard library. And what are we doing? We're seeing the screen right now. Again, we're using LookDevX to combine those 5 patterns into the outer the new shadow definitions. The customer can actually simply use it and use it in the pretty much easiest way. What you see right now is basically 5 patterns like exposed with their parameters in the compound that can possibly later can be published. I actually already used that in some of the materials, and possibly one of my favorite one is the last one that we're going to see on the screen right now, which can be easily used for the creating some kind of tiles. And yeah, quite awesome improvements from our platform team, graphics team. Native MaterialX authoring, it's something that we promised a long time ago, and we're actually doing it right now. It is in prototype stage, but it's actually, we're going to see that we actually moved so really, really far. So you can create your MaterialX document in the Maya DG. You can obviously load material document on, you can load it in your LookDevX. And right now, finally, we have like a proper agnostic editor where you can have like a native USD material authoring happening on one side in the same scene, or you can go to different tab and create native MaterialX materials. You can author in there. So what you see on the screen right now, it's a little bit rough. You can probably expect with time, we're going to just like match. We're going to get to the point we can possibly match USD UX with the MaterialX side. So in this case, nothing's going to change. Whatever you're doing in the USD side will be actually supported big time in MaterialX side. Regarding assigning materials, currently we can do it in the USD. Maya is still not supported, so you have to reference materials to USD, which is common process. In this case, we did it just in that scene. And then you can start using things that we already developed for the USD, which is material assignment, direct material assignment, and color management. In case if you want to just use the color managed color picker, you can suddenly start sampling images, colors, and assigning it to the different geometry. You can print your shaders to the strip editor, or you can save it to your disk if you want to. Obviously, you want to save MaterialX file to MTLX file. You can load materials into your document too. And in this case, I was just creating some kind of interesting material that is fairly simple, I would say mid complexity, where you have like bound displacements and all kind of basic stuff. You can assign directly with Arnold running in the background, and then you're going to see where we're getting. Yeah, so important to say, like Arnold is pretty much supporting everything what we're doing, like, and that's great. But on top of this, it's good to say that our viewport is really doing a great job, and that's pretty much what you see in viewports. This is the list. Next list is pretty much the features and the workflows that we are considering to working on. I possibly want to highlight a few of them, which is publishing workflow, preset, and rump. And that's pretty much the group that we want to possibly working on as a next one in the line. If you have any comments on the list, don't hesitate to join our beta forum where you can get involved, and hopefully we can set up some priorities and add some kind of new ideas to us. Finally, the few big items to consider is like listed here on this slide. Definitely we will work closely with our Hydra team and community, making sure we can represent accurate pixels by Arnold or any of the delegates within Hydra. Natural next step regarding the MaterialX is the Maya native support, where we will finalize the round 3 between material workflows between Maya and USD Geo. 3ds Max eventually will be our next integration. That's still to be determined when. And finally, the Bifrost USD is, as you probably can see, seen before, is like his natural candidate for handling the procedural or late material binding. We will definitely continue working with our Bifrost USD team and making sure that our workflows are connected and easy to use for any type of the artist. That's pretty much from me. I'm handing over to Magnus.
So, hi. Hope you all can hear and see me. Otherwise, you need to shout out. Thanks, Nikola. I'm Magnus Pettersson, work for IKEA with 3D development. I'm going to talk a little bit about our Strolla editor today and how we designed that from a technical point of view. But first, I guess I need to talk a little bit about why we're interested in MaterialX at all. Because IKEA comes from a place where we used to do everything with pictures in the catalog, but now we're very rapidly moving into a multi-channel landscape where we do AR and VR apps, game-like experience, web planners, videos, and of course, pictures. So as you can imagine, there's quite a lot of render engines and game engines that we need to leverage to build all these experiences. And here is where we really feel like MaterialX and then of course USD can be the focal point where we start everything, where we author all our content, and then it feeds into all these experiences. And that's also why it's so nice to see like the OpenPBR initiative, because that's also something that would close this content gap. But when we started with this, there were no editor for MaterialX, so we had to write one. Now there's a bunch of them, which is great, and you'll see some more today, I know. But when we started, we couldn't just have our artists edit XML files, so we had to write something. So we wrote a C++ program on top of the, I used the dear EMGUI and the node editor packages to build the front end and the graph part of it, which is actually the same things as the MaterialX editor in the repo does nowadays as well. Then we use the OSL or Open Shading Language backend to generate code, and OSL, of course, then to make images out of that. We use OpenImageIO extensively for texture handling, another great Academy software project. And we have a modified version of the Open Shading Language test render for previews, and we'll talk more about that later. So this is how it looks like. It's pretty standard, like node editing layout. There is all the standard nodes from MaterialX and our IKEA nodes are available. Once you connect something, everything updates. We have tried to color code everything so you can see when you do valid connections, stuff like that. This is just an example. It's one of the AMD materials from their material library. And I'm just adding a saturation node to show how it works, basically. So when it comes to swatches, everything you see is rendered on the CPU using OSL. And the reason for this is basically twofold. We didn't want to get into too much of like the GPU drivers compatibility issues that you can hit. And we also have a tendency to use very large textures at IKEA. And that's also very hard to support on a variety of GPUs. We initially thought that we would need to move this thing to the GPU for interactivity reasons, but it turns out that modern CPUs are pretty fast, so it hasn't been a problem so far. And since we're all on the CPU, we can use OpenImageIO and the texture cache. So even though we use very large textures, we use texture caching functionality and pre-tile and mip-map everything. So we have just like 1 gigabyte of texture cache that works very fine for us. When it comes to previewing, we wanted a path tracer because we want to alter the photoreal materials. So what we did was that we took the OSL test render, since that was closely related to MaterialX and had most of the closures, and we modified it a little bit so we can load triangular meshes, and we modified the render loop a little bit so it's more interactive. And as you can see, when we tumble around, we're not actually path tracing anymore, we're just gray casting to draw some interactivity back. But this works very well for us. But I think that it would be really nice to have a reference path tracer as part of the MaterialX distribution for everyone's benefit. And last but not least, real time is super important for us as well, because, well, we do a lot of things with the web. So here we're using the translation graphs to translate from standard surface materials, which is what we use, and into the GLTF PBR model. And then we just bake out the subgraphs to some reasonable texture size, like 1K or 2K, depending on the project. But this works really well so far. And we're really hoping to dig into the OpenPBR stuff as a next step for this. Also, I should mention, we really believe in MaterialX, so we're hoping to be able to contribute back some parts of this to the projects. We haven't really decided on what and how to do that just yet, but it's certainly our intention to do so. So that's all that I have. And now I guess it's time for Kai from NVIDIA to talk a little bit.
Yeah, hi. Yeah, I get started. Hi, I'm Kai Rohmer, software engineer in the MDL team at NVIDIA, and I'm going to talk about our latest contributions to MaterialX. And yeah, we all know what MaterialX is. It's an open standard for representing material graphs in computer graphics. It offers a physically based shading nodes along with standard nodes for compositing materials based on graphs or networks. And the most important part for us, the shader generator, which allows to transform the MaterialX descriptions into code of the target language for your specific renderer. And this is where MDL comes into play, because MDL is such a target language. It's domain specific, it's designed for creating highest fidelity materials that are evaluated on parallel architectures. And we offer a graph-based system to define complex materials for physically based rendering, along with user-defined procedurals that drive the inputs of our materials. And after designing, we can feed the materials into our backends to generate executable code in your renderer's shading language. And that code is easy to integrate because the sample eval interface that we offer is agnostic to the algorithms the renderer uses, or rendering algorithms in general. And important to mention, MDL is open source for several years as well on GitHub. So because of all of that, MDL is an excellent language to implement MaterialX. And together with Autodesk, we created a shader gen component that transforms materials described by a network of MaterialX nodes to MDL, which backs then the MaterialX node implementations. The resulting library called MaterialX Gen MDL has been released as open source as well, and it's available in the official MaterialX GitHub repo for a couple of releases now. It's already used in VRED and drives the MaterialX integration in NVIDIA Omniverse. We are the most complete open source implementation, and we are constantly working on improvements and updates, and a few of them I want to point out on the next slides. So one of my first updates in the last year was improving the integration of MDL code generator in the test suite. Our open source example renderer can now match the test scene, and this allows better comparison with other shader gen targets. And here in this screenshot, you can see a comparison between GLSL, OSL, and MDL, along with difference images, which are pretty black, which is perfect. The first actual feature update was the generalization of our sheen node implementation, which can now be layered on top of any node. And before, we only allowed to specify a diffuse base color. So this is a bit more flexibility. Then we added proper support for thin film over dielectrics and metals, as well as thin film on top of layers that contain receiving nodes somewhere deeper in the hierarchy below. Then there is the new generalized Schlick emission node. And for this one, we have been involved in the design and worked with Niklas Harrison on the specification that works well with MDL. There have been a few more updates in the 1.3.8.7 release that I just listed here for reference. This includes emissive volumes, arbitrary weights for add BSDF, EDF, and VDF nodes, non-uniform weights for the mix EDF node, and a couple of more, but I'll skip over them to show you a bit more of the current work we are doing at the moment. The latest approved but not yet released pull request is support for displacements. So we also added that. And we are currently working on adding an option to specify the MDL version that the shader generator will emit. And this gives more flexibility for update cycles in integrations, which is an important aspect, as we believe. And as I already mentioned, MaterialX is available in NVIDIA Omniverse. And we are using MaterialX Gen MDL for the RTX renderers and iRay. And currently we're working on the authoring of MaterialX node graphs based on USD shade. And I want to show you a little preview of that here as well. Since node graph editors for MaterialX are a big thing in this session here, so we join in as well. And All right, this is already my last slide. Thanks very much. And yeah, I'm passing on to the next one.
All right, hello everybody. I think I am the next one. So let me go ahead and share my screen just for a moment. Okay, hello everybody. My name is Mark Manca, and I lead the strategy effort for RenderMan. And I'm here to talk about where we are with RenderMan and MaterialX. Now, MaterialX obviously has wide applications. I mean, there's examples from several industries in this talk, or not in this talk, but in this virtual town hall. But because of RenderMan's focus, our focus on film, streaming, advertising, the lens that I'm going to bring to this talk is that, right? So we'll be talking about it in the context of kind of film production, quote unquote, kind of workflows. But before I talk about kind of where RenderMan is today and where we're going, I always like to state the obvious. I think it's really good for us to periodically take a step back and talk about kind of why we're here and what we're doing and why. So these things I think we all intuitively know. They've been talked about in various talks, from the first MaterialX talk several years ago onwards. But I think it's worth repeating and worth talking about at least how we as RenderMan are looking at MaterialX and all of its different applications. And really that it's something about the notion of allowing artists to create an asset once, but then be able to use it anywhere. And in my mind, there's two big reasons for that. The first is a creative one, that the artist puts a lot of effort into creating something that just looks amazing. And the expectation and the hope is all that creativity then makes its way forward into all of the different places that the asset is going to be used. But the other is cost, right? In this era of studios needing to be even more efficient, there's also cost reasons to want that interchange to also be true. You don't want to have to create different versions of the asset for kind of different applications that a single studio might need it for. So it's kind of this duality of creativity and cost consciousness that drives this notion to create once and use anywhere, for which MaterialX is perfectly positioned. For us, in thinking about production workflows and the complexity of production pipelines, that's where RenderMan's sweet spot around creating final frame renderers for streaming. But then being able to reuse that asset, for GL previews, for different disciplines and different DCCs. Every VFX studio seems to have an LED wall now with some sort of real-time or game engine driven renderer, and you want to reuse the assets there. Digital backlots, hugely important. If you're talking about the Disney ecosystem, you're talking about theme parks as well, and how do you reuse assets for those? And then, of course, there's also interchange with other studios. And I'll admit that we hope that all those studios use RenderMan, but if not, we know that that's not the case, and that the clients do expect a level of kind of cost efficiency with these assets, and transitioning to other studios is hugely important. So again, I think we know all of these things. I'm just stating the obvious, but I did want to kind of jump up as to why we're interested in this. Pipelines are hugely sophisticated. The types of renderers that they drive and the use cases within studios for those pipelines are enormous. And one of RenderMan's strengths, one of our DNA's, critical pieces of DNA, is to be able to plug into those pipelines and embrace those pipelines. And so, what we do already for MaterialX and then what we're doing in the future is hugely important for us. So let's talk about where we are today. So this is the open chess set. And where we are today is we support MaterialX via the USD and Hydra pathway. So a huge thank you to Karen and all of the USD and Hydra teams, because it's that pathway that enables this. So this was rendered via Solaris and goes through HDPRman and off to RenderMan. So, there's a richness of materials that are available there. Now, how this works is the translation goes to Pixar surface, right? So, shader gen, the way it is it's meant to be that kind of intermediary that takes the arbitrary definition and allows the specificity of a particular renderer to be, it's that bridge between the specificity of the renderer and the generality of MaterialX. And for us, that means translating to Pixar surface. We've also been involved with MaterialX with Llama. MaterialX Llama is a production-proven shading system from ILM. Llama, or MaterialX Llama, to use the proper terminology, has been used for many years there, and is basically at the heart of how they do look development for all of their productions. And what's interesting is a subset of MaterialX Llama is what is also used to drive the materials on stagecraft. So they're real-time LED walls. So MaterialX Llama is hugely important for the way they work. It is extremely production proven, and it's something that we have brought forward into RenderMan, and is something that continues to evolve and is a part of the MaterialX kind of suite of technologies. So this one's hugely important for us, and this car, if you hadn't guessed, is LookDev with Llama. But where are we going? Before we talk about where we're going, I have to acknowledge Nikola and his slide of legal language, because even though we don't have such a slide, it applies equally well to us. So thank you, Nikola, for that. Because we're talking about the future here. We don't necessarily have timelines for any of this, but it is things that we are actively working on. What we're working on is to first bring MaterialX Llama to XPU. That's not there yet, and it's something we are actively working on. But in order to do that, we've gone back to the drawing board a little bit. I talked about how shader gen provides that bridge or the glue between the generality of MaterialX and the specificity of a renderer. And right now for us, that is Pixar surface is the specificity for us. But we're working to generalize that. The place that we want to get to is where we are providing direct support down to kind of the OSL primitive closures. I like to call them the lobe primitives that make up the PBS definitions inside of MaterialX, so that they can be combined in with the same level of arbitrariness and flexibility that MaterialX offers. So this is all something we're bringing to XPU. And is something we're working towards. We want to make sure we're enabled the full flexibility of what MaterialX has to offer inside of RenderMan. And that's the end of my portion of the talk. So I'll hand it over to Manuel and Richard to talk about Quilts.
Thank you, Mark. All right, thank you for everyone attending today. My name is Manuel Köster, and I'm currently working for Remedy Entertainment. And I'm here today together with my good friend Richard Frankenberg, who's the founder of Prism Pipeline. And today we will be bringing Quilts to you. What is Quilts? Quilts, like many of the other things you've seen today, is a material node editor based on MaterialX. It allows you to mainly export and import materials based on MaterialX, but it also allows you to preview your shaded assets based on USD's Hydra, which is running in the viewport within Quilts. Now, why did we create Quilts? Sometime before SIGGRAPH last year, Richard and me came together, and we were just amazed at how great the USD ecosystem is coming out to be, and all the companies joining together. And MaterialX was also really shaping up to be a really, really great thing within this ecosystem. But there wasn't really anything out there yet to be able to really easily create and export MaterialX shaders and kind of interchange them with the different systems. So we wanted to create something, and it needed to be artist friendly, first of all. And also it needed to be able to show the material within any of the Hydra renderers. So we wanted to make sure that Hydra gets integrated. It also needed to be really easily integrated into any DCC and pipeline, because we know how important it is to kind of be integrated, for a tool to be integrated into a pipeline. And in addition to that, since the whole ecosystem is so great and it's all open source, we really wanted to make sure that the tool would also be open source. Now let's jump into a demo. This is Quilts, what you're seeing, and in the viewport currently is running Storm, and I'm just playing around on a kind of default shader ball. And now we just switch to Arnold, and you can see that nothing really changed in the viewport, besides like everything looking a bit sharper and nicer, and everything being a bit more shiny. Now I'm dragging in MaterialX material just from my file explorer. And one of the things we really wanted to make sure is that the interactivity for the user was there. So the user can drag on a slider and you can see everything update in real time. And also to be able kind of to drag in anything into the editor, how the artist might be used to things. Now, but let's create a material from scratch. Magnus actually has a very good taste in material selection, because we seem to have picked the same material from the MaterialX MD library. And here I'm just adding a couple of nodes, the normal map node here. And additionally to that, increasing the UV tiling a bit. And this is our final kind of shader being previewed in Arnold in the viewport using Hydra. And now I'll hand it off to Richard.
Right, thank you. So I will talk a bit about pipeline integration and node graphs. So as we saw, like for very simple materials, we can create all our nodes on the top level. But once we have like more complex materials with dozens of nodes, usually we want to create subgraphs and then store our more complex logic in there, and only expose the relevant parameters to the artists, which they need to control. These node graphs can then be easily saved to disk so that they can be reused in other materials in the project. And it's also possible to edit the node definitions of existing materials and nodes. So it's possible to create different variations and different versions of node definitions. Let's have a look at how that looks inside of Quilts. So there's the node graph node where we can dive into, and in here we can create our node graphs. In this case, I create a texture node and a mix node, and I expose the file path and the mix value to the top level. So the artist only sees these parameters which are exposed, and it's quite easy for them to see which parameters are relevant to work on the material. It's then also very easy to save out this node graph to disk as a file. And on other materials, this node definition can then be loaded. It's possible to make an editable copy of it and dive into it to make any changes if needed. And then it can be used on different materials within the pipeline. So Quilts is written completely in Python and PySide. So integrating it into a studio pipeline is really easy. So all the different widgets, like the viewport, for example, or the USD scene graph tree, they can be all replaced with custom widgets if studios already have these kind of widgets in their pipeline. It's also possible to add new menus to the menu bar, for example, to trigger some custom publish processes. Here I have an example where I have a custom library panel in Quilts, and from here I can drag and drop HDRIs into the viewport or textures into the node graph. Here's another example where I have a custom USD scene graph widget where I can change the USD prim hierarchy. And I also have a custom viewport widget where I can change the shading mode and the USD complexity. So all the different widgets are very decoupled from each other and extensible. So if you only need the node graph, you don't need to use the viewport at all, or you don't need to use the USD scene graph. Many things can be customized using environment variables, and especially the Hydra delegates. For example, if you want to add your own Hydra delegates, that's easily possible. And there are also some other settings in Quilts which can be customized like that. We already provide some pre-built binaries for MaterialX and USD on Windows, but of course you can use your own builds. Yeah, whatever you use already in your studio, you can use with Quilts. Quilts is released under the Apache license, which is a very well-known license for open source projects. So from a legal perspective, it should be very straightforward to integrate Quilts into studio pipelines. Here we can see the different projects which Quilts is based on. Obviously, it's MaterialX, USD, Python, and PySite. And for the node graph itself, we are using the node graph Qt project, and we are using Qt.py for being compatible with different PySite versions. So we were developing mostly with USD 22.08 and the MaterialX version came with it by default. And we are also providing some pre-built Arnold binaries. So it basically comes out of the box with a production renderer. We already experimented with the latest USD version, which works very well in Quilts, but we still need to test a bit more to see which Hydra delegates are compatible with this version yet. It's also possible to run Quilts in an Houdini environment, which allows us then to use side effects Karma and other Hydra delegates which are available in this environment. And as already mentioned, you can use other USD and MaterialX versions, but this is untested at the moment. Right, and I hand it back to Manu.
Thank you. Now let's take a closer look at how Quilts works and the technical implementations of things. Now there's three main elements in Quilts which the user interacts with. It's the node graph and its properties, the scene graph or the stage tree, and the viewport. And how does the data travel along until we see a final picture? First off, we start off with the node graph and properties, which get translated to MaterialX data directly into a MaterialX XML string, and this gets then kind of imported into a USD shading layer. We have two kind of main shading layers, the shading layer and the assignment layer, where we bind the materials of the shading layer to the other USD prims, like the shader ball, for example. All these layers then get sublayered into a USD stage, which then gets handed off to Hydra, which then renders our final image on whatever kind of render delegate that is currently selected. This all is kind of happening within USD view stage view. And yeah, what are our next steps? We want to focus on the continuous integration and continuous development a bit, as well as mainly we want to kind of deepen the collaboration between with the community and the libraries that we're using. And we're really eager to get more features in, for example, the color space support that Karen teased us with earlier, and hopefully a lot more. And yeah, thanks to a lot of all the companies and projects currently on the slide, mainly the AMD GPU Open Material Library, as well as Arnold, who made this presentation possible. So thank you. And yeah, finally, we are proud to announce that Quilts Open Beta is available today. Feel free to either have a look at the, or not just have a look, but scan the QR code or go to the link. I think Richard will also be posting that in the chat. It will be released today, and you can have it today on your desktop. And I think that is it for us, and thank you.
Thank you so much, everyone. And yeah, thanks for that final slide. That answers one of the questions in the chat, which was, when will the public beta of Quilts be coming out? I'll definitely check that out. Let me see if I can share a slide with our questions page. And let's see, how much time do we have? I think we're a little bit over. Emily, would it be okay if we were to answer a few questions nonetheless?
Yeah, you won't get kicked off. So if people are able to, if people are able to stay on, then you can keep going.
Okay, let's do it. And yeah, feel free to stay on if you're interested in the questions and answers. There's some really good ones here. I'll do them in chronological order. The first couple were generic questions about the MaterialX project itself. One is, do you plan to implement a proper fur shading model in MaterialX? That's a great question. So far, we've only talked about hair shading models, and we're very interested in adding a Chang hair node that it would be similar to the MaterialX Llama Chang hair node, but we would like to collaborate with other teams to get the interface exactly right for that. As the poster notes, that's not exactly the same as a fur shading node. There are other BSDFs that are used for that purpose, and we actually haven't yet discussed that. So we'd love for someone to propose what is a good BSDF for fur shading, and could it potentially be made available across all shading languages? In other words, is it generic enough that it makes sense as a built-in OSL closure and a built-in MDL closure? And if it reaches that level, as I believe Chang hair shading does, we'd be very interested in adding it to MaterialX, working with those teams to make sure that the closures are implemented everywhere, and then making that available. So that's a great question. I'll also make the point that if you want to propose a specific node like that, the best place to do that is the MaterialX channel on the ASWF Slack. And you can find that on aswf.io, or you can just Google for ASWF Slack, and you'll find it as the first hit. So that's a great place to propose new nodes, and there are a bunch of new nodes in development from various teams, and we'd love to have more people in that conversation. The second question was, any chance of getting ramp in MaterialX? Yes, we're very aware that that is something we need. We intend to add curve adjustment and ramp implementations in MaterialX 1.39. It's something where the implementation in hardware shading languages is tricky, and so we have deferred that until we have a chance to work through the details. Any contributions from the community on that, or ideas on good approaches, would be appreciated, but it is something that is already planned. Houdini did a great job of implementing a MaterialX style ramp node that we believe provides a really good model for the one that would be integrated into MaterialX itself, but there's a bit more work needed there. So that's something that is planned, but we don't have yet. Then there's a bunch of questions for Nikola about LookDevX. I think probably the LookDevX beta will be the right place to address these, but I'll bring up the first one just in case Nikola wants to weigh in. The question is there a browser that will show me all LookDevX MaterialX materials in the scene? Nikola, did you want to tackle that one?
Thank you, Jonathan. So currently we don't have it. We do have a design done so far regarding the browser, and we did one prototype already. Additionally, we even have a material library that we want to share with the community freely, so for everyone to actually use it, and we will actually use the browser to deliver that. So so far, no. Is it in plans? Yes. And additionally, Bifrost team is working on something similar, so we can probably expect something happen in some future, as I'm not able to talk about future.
They're trying to trick you into talking about the future. Yeah, I think, and I know there's a LookDevX beta program that's part of the Maya beta program. These are probably great questions for that.
Yes. My beta program is open. Everyone is more development to join. It's easy to join. Yeah, and there's a lot of stuff there we can just like expose to everyone, like, and especially those designs. Exactly, there was a lot of questions about how to hide nodes, hide connections, and we have a lot of amazing approaches where we're gonna probably make your life easier when you're creating very complex graphs. There's one question that I really want to possibly address, if I can, Jonathan, because I think it's really interesting for everyone, if you don't mind. But it's just like, it's basically a question about like, is it possible to create LookDevX? No, sorry, yeah. Is it possible to create LookDevX material and assign it to any geo in Maya procedurally? That's quite a cool question, to be honest, like, because this is something that I was working hard, and possibly Jonathan saw that a few years ago in some designs, where we want to have a universal material assignment where you can actually assign material to any kind of different data models. Not for now, but I feel really strong about it, and I think there's a need right now with MaterialX. There's a great opportunity to actually tackle like different data models, like in a way that we can assign it to USD and Maya geometry at the same time, and have like proper round trip between the different data models. And that's something I feel that we're going to get to that point.
Thanks, Nikola. Yeah, those are great answers. I'll bring up one other question in the Q&A. I see some folks are posting in the chat. It would be better to post in the Q&A if you can, because that'll be tracked. So the next question in the Q&A is, have the existing Llama nodes been considered when discussing OpenPBR? I can address the Llama side of that, just because to my mind, they address very different use cases. So Llama is effectively a higher granularity toolbox for composing complex Uber shaders, but it is not itself an Uber shader or a surface shading model in the sense that OpenPBR is. So I wouldn't imagine that you would want to use one in place of the other in the same situation. Llama still has a great value in allowing artists to compose multi-layered BSDF systems that are bespoke to a particular asset that they're working on. But that's very different from an Uber shader or a shading model, where you can enforce continuity across an entire pipeline, and you can guarantee that an asset you've created in one renderer will translate seamlessly into another because they both support this common Uber shader. So I think, to my mind, they're just tackling very different needs. For members of the OpenPBR team, did you want to weigh in on that as well? Since I would imagine you would have good thoughts.
I can add something there. So we've had customers taking the Autodesk standard surface spec and implement it using Llama nodes. And I would be very surprised if it's not possible to do the same exact thing with OpenPBR. The idea of the spec is really for implementers. You take the spec and you implement it with your own native implementation, and Llama would be, I think, a suitable implementation of it.
Yeah, that's a great point. You could compose OpenPBR from the Llama nodes in many situations. Essentially, you could think of Llama as a higher granularity level set of BSDFs, where you can't compose everything that MaterialX can, but you can compose a reasonable artistic facing subset of those. Let's see, we have a great question here from Charles de Roussier at Epic Games. Is there a particular reason why OpenPBR's slab node has a coat lobe? Such a coat lobe can be represented as a layering operator, or is that for performance reasons? This is definitely for Adrien.
I'm not sure I followed the question exactly. Is the question, why do we have an explicit coat slab or lobe?
Yes, exactly. Like it looks like your slab node has like an extra like coat layer on it.
Yes.
And I was wondering why would you have such a coat, while you could express that again with like a layering operator instead?
So the coat is expressed with layering inside OpenPBR, and the coat is something that is the coat layer is a tool in Uber shader that users are very used to. Like we have a coat layer in standard surface. Adobe has a coat layer in standard material, and it's something that is very common. It's just and the point you're making is a great point. It's a point you can make about any of the parameters of OpenPBR. You could not have an SSS component and use a layer operator to add the SSS component. You could do the same thing with Sheen. And basically you end up by recreating an Uber shader with just layers. So it's a balance between simplicity and not being able to represent most materials within a single shader. And coat is very much part of that, because coat is present on a huge portion of the real world materials. So if it's there, we need to have it in OpenPBR. But we are making an explicit decision about any of those parameters, thinking of it like that. Can we represent most materials with that set of parameters? And whilst striving not to have 80 or 90 parameters on the Herubel shader because that is unpractical. Does that answer your question?
Yeah, perfect. Thank you very much.
If I can add something to this is, yes, we can make something as complex as we want, but we don't want it to be complex. We really want to, it's a difficult choice to take the parameters that are most used so that it's simple for an artist to get to know the model. It's also, if you have the ability to compose everything in layers, sure, you can be more expressive, but it's difficult for any artist to jump in and just use the material. You have to know how it's composed, how it works. You have to dive into it to see, oh, this is the layering. An Herubel shader allows any artist to jump in. If it's open PBR, I know how it works. You can just use all the layers. So it is a balance for sure.
Yeah, makes sense.
Thanks so much. We have one more question that I think is worth bringing up here, perhaps as our last question. I've heard there's initial discussion for GLTF to have an extension for MaterialX. How could that work in practice? Would this extension potentially have full support of MaterialX or a more limited subset of features? This is a discussion that is currently happening within the Metaverse Standards Forum. And it's a great question that doesn't have a final answer yet, but it does seem likely that support will start with a subset of MaterialX features and build towards full MaterialX support in the future. Kronos and the GLTF team have done a lot of thinking about how graph-based materials like MaterialX can be integrated in the future. They would like the representation for that to be MaterialX, providing exchange between GLTF and USD files. But there's a lot of work to be done there, and the needs of the web are different than the needs of production DCC tools. So I think that'll be an ongoing discussion, and I can provide a link to the Metaverse Standards Forum where a lot of those discussions are taking place now. If we don't have any other questions, maybe that's it for us. Thank you so much to all of our amazing presenters and to the folks who were able to attend today, and to the folks who asked all the great questions. You can find the MaterialX project on GitHub, and you can find the discussion space for it on the ASWF Slack organization. I encourage you to find us in either or both of those places, and we look forward to future conversations with the community. Thanks so much.